Welcome to Review Central's Civil Service Exam Reviewer number 3, featuring questions on numerical ability. This reviewer is intended for those who are eyeing, or are set to take, the Philippine Civil Service Exam, also known as the Career Service Eligibility Exam. The exam's numerical ability subtest is for both professional and sub-professional level eligibility.
There are 25 carefully curated questions featured on this reviewer. All questions are modeled on actual questions that appeared on previous civil service exams. Take note that most, if not all numerical ability questions in the civil service exam involve only basic mathematical principles and applications, and are relatively easy and quick to solve. If you have finished at least secondary education, and with sufficient enough review, there is no doubt that you can solve all numerical ability problems in the civil service exam. The question is, can you finish solving all of them in the given amount of time? Therefore, you need to focus on techniques. Most numerical ability problems herewith can be solved within 15 to 30 seconds, if you employ the right techniques, that is. As you go through the following questions, you are encouraged to pause the video right after each question and attempt to answer the question yourself. Give yourself no more than 45 seconds, and attempt to actually solve each problem in only 30 seconds or less.
Before we proceed, don't forget to subscribe to Review Central and click or press the bell button to make sure you get notified whenever we post a new reviewer or other review materials on this channel. Now let's begin.
Question number 1. 40% of what number is 25% of 40? A. 10. B. 20. C. 25. D. 50. The correct answer is C. 25. Simple percentage problems like this are a staple of the civil service exam numerical subtest, so it will suit you well to brush up on your percentages. Let's proceed to solve this simple percentage problem. We can express the problem into an equation as follows. 0.4x equals 0.25 times 40. We simply do the necessary algebraic transpositions and should quickly arrive at x equals 25. By the way, working with percentages necessitates that you should also be adept at working with decimal numbers. In the above solution, you may be wondering how we got rid of the decimal numbers and ended up with an integer, 25, as the answer. The quick answer to that question is, we moved the decimal points 2 positions to the right on both the numerator and the denominator. We ended up with 25 times 40 in the numerator and 40 in the denominator. We simply cancelled out 40 and is left with 25. Another way to put it is that we multiplied both numerator and denominator by 100, and came up with the same exact result.
Question number 2. If 1 plus 2 plus 3 plus 4 plus 5, plus 6 plus 7 plus 8 plus 9 plus 10 equals 55, then 101 plus 102 plus 103 plus 104 plus 105 plus 106 plus 107 plus 108 plus 109 plus 110 must be equal to A. 955, B. 1055, C. 1065, D. 5055. The correct answer is B. 1055. This is one of those civil service exam numerical ability questions that require you to use certain techniques. Sure, you can go ahead and try to do longhand addition on all the given numbers and you will arrive at the correct answer for sure, but that will probably take you at least a minute to complete. Or you can solve it using our suggested technique, as follows. Since 1 plus 2 plus 3, all the way to plus 10 is already given as 55, then 101 plus 102 plus 103, all the way to plus 110, is simply 10 times 100, plus 55. Did you follow?
Question number 3. Solve. 1/2 times 2/3 times 3/4 times 4/5 times 5/6 times 6/7 times 7/8 times 8/9 equals A. 7/18, B. 1/9, C. 4/27, D. 1. The correct answer is B. 1/9. Problems involving fractions are another set of questions that abound in the civil service exam numerical ability subtest. A lot of people are uncomfortable with fractions. When they see a problem involving several fractions, like this one, they either freeze and blank out, or they simply skip the question immediately. But if you know the applicable principle and the technique associated with it, you will find that this is actually one of the easiest and fastest to solve. Don't let the long string of fractions scare you. The solution is actually very easy, and you may even laugh at yourself when you finally figure it out. Here's how it goes. Since this involves multiplication of several fractions, then the first thing that you should do is to find numerators that can be cancelled out with the denominators. And guess what? Practically all the numerators and denominators can be cancelled out, leaving only 1 in the numerator and 9 in the denominator. Therefore, the answer to this problem is simply 1 over 9.
Question number 4. Evaluate 2 times 16 minus the quantity 24 minus 6 divided by 3 plus 22 minus 2 cubed. A. 14.67. B. 36. C. 40. D. 48. The correct answer is C. 40. This is simply a problem involving PEMDAS. You do recall your PEMDAS rule, right? Okay, just in case you've forgotten all about it, it is the rule for the order of operation in basic arithmetic. It stands for parentheses, exponents, multiplication, division, addition, and subtraction. It is known by many different names in different parts of the world. It is also called PEMDAS, BEDMAS, BIMDAS, BIDMAS, BIMDAS, BODMAS, BOMDAS, and so on, but they are all basically the same. Okay, let's proceed to solve this problem, and for sure PEMDAS will all come back to you. First step, resolve the parenthesis. 24 minus 6 equals 18. Second step, resolve exponent. 2 cubed is equal to 2 times 2 times 2, which is equal to 8. Third step, resolve multiplications and divisions, from left to right. 2 times 16 is 32, and then 18 divided by 3 is 6. And for our fourth and last step, resolve additions and subtractions, from left to right. That's 32 minus 6 plus 22 minus 8, which is equal to 40. And 40 is our correct and final answer.
Question number 5. State the property illustrated. If 8 times 6 plus 4 equals 48 plus 4, and 48 plus 4 equals 52, then 8 times 6 plus 4 equals 52. A. Associative property. B. Transitive property of equality. C. Commutative property of addition. D. Distributive property of multiplication over addition. The correct answer is B. Transitive property of equality. The definition of the transitive property of equality by Euclid is simple. He defines it as, things which are equal to the same thing are also equal to each other.
Question number 6. Find the sum. 299 plus 945 plus 398 plus 99. A. 1531. B. 1641. C. 1741. D. 122,222. The correct answer is C. 1741. Questions like this are intended to test how fast you can do your longhand addition, so there's no escaping it. Since you are not allowed to use a calculator in the actual exam, grab your pen and paper and do this addition by longhand as quick as you can. Lots of practice will surely help. If you know rapid math techniques like forward addition, that will surely help you gain a few precious seconds. Whatever it is, use the technique or procedure you are most familiar and comfortable with. However you intend to solve it, you should arrive at 1741 as the correct answer.
Question number 7. Find the quotient. 8,000 divided by 125. A. 48. B. 64. C. 80. D. 88. The correct answer is B. 64. You may go ahead and solve this using longhand division and arrive at the correct answer in a fairly short time. Or you can first recognize that 125 is equal to 1000 divided by 8, and then proceed to divide 8000 over 1, which is simply our original 8000, by 1000 over 8. Next, apply the KCF technique in dividing fractions. That is, K for keep. Keep the first fraction as is. 8000 over 1. C for change the operation from division to multiplication. And then F for flip. Flip the numerator and denominator of the second fraction from 1000 over 8 to 8 over 1000. As you can see, we can cancel out the 3 zeros and is left with simply 8 times 8, which is equal to 64.
Question number 8. Rounding 499,921 to the nearest thousands, the result is A. 499,920 B. 499,000 C. 499,900 D. 500,000. The correct answer is D. 500,000. To round off numbers to the nearest thousands, we drop off the last 3 digits and replace it by 3 zeros. Retain the fourth digit if the number dropped off is less than 500. Add 1 to the fourth digit if the digit dropped off is 500 or more. Therefore 499,921 is almost equal to 500,000.
Question number 9. Which of the following statements is true? A. If a number is divisible by 3, then it is divisible by 6. B. If a number is divisible by 4, then it is divisible by 8. C. If a number is divisible by 5, then it is divisible by 10. D. If a number is divisible by 10, then it is divisible by 5. The correct answer is D. If a number is divisible by 10, then it is divisible by 5. Let's inspect and evaluate each of the given answer choices. Answer choice A. If a number is divisible by 3, then it is divisible by 6. Let's take the number 9 as an example. 9 is divisible by 3, but not by 6. Therefore A is not true. Answer choice B. If a number is divisible by 4, then it is divisible by 8. Let's use number 12 for this illustration. 12 is divisible by 4 but not by 8. Therefore B is also not true. Answer choice C. If a number is divisible by 5, then it is divisible by 10. Let's use 15. 15 is divisible by 5 but not by 10. Therefore, C is likewise not true. So we're left with answer choice D. If a number is divisible by 10, then it is divisible by 5. Let's use 10 this time. 10 is divisible by 10 and also by 5. We can also try 190. 190 is divisible by 10 and also by 5. Therefore, D is true.
Question number 10. What is the remainder when 1,245,192,888 is divided by 8? A. 0 B. 1 C. 4 D. 7. The correct answer is A. 0. Without a calculator, it may seem extremely tedious, if not almost impossible, to solve this problem in the limited amount of time you have in the exam. Most exam takers will simply skip it or guess the answer. In fact, you don't need to worry about the huge number and the dividend at all. There's this special mathematical phenomenon involved when dividing any number by 8. Did you know that a number is divisible by 8, that is, the quotient is an integer, if the number representing its last 3 digits is divisible by 8? It doesn't matter what the other digits of the number are, or how big the number is, as long as the number representing its last 3 digits is divisible by 8, the number itself is divisible by 8. Go ahead and try this on your calculator. Multiply any number with 8 to come up with a 3-digit number, and then append any number of random digits to the left of that number, and then divide the resulting new number by 8. The result will invariably be an integer. Amazing, right? Since the number represented by the last 3 digits of 1,245,192,888, that is, 888, is divisible by 8, the quotient is an integer, which means that the remainder is 0. Question
number 11. Find the value of x, where x equals 3 over 8 times 72, plus 5 over 7 times 35. A. 27. B. 36. C. 45. D. 52. The correct answer is D. 52. This is a simple problem involving multiplication and addition of integers and fractions. The key here is to find the value of x in the shortest time possible, and the way to do it is to find values that can be cancelled out first before proceeding with any multiplication. In this case, 72 and 8 can be cancelled out, leaving 3 times 9 for the first term, and then 35 and 7 can also be cancelled out, leaving 5 times 5 for the second term. From here we should quickly arrive at 52 as the correct answer.
Question number 12. Reduce 231 over 1001 to its lowest term. A. 7 over 11. B. 3 over 31. C. 3 over 13. D. 7 over 13. The correct answer is C. 3 over 13. A fraction is in its lowest term if its numerator and denominator are relatively prime, that is, their greatest common factor is 1. To reduce a fraction to its lowest term, divide both numerator and the denominator by their greatest common factor, or GCF. The question is, how do we find the GCF of 231 and 1001? The problem in finding GCF is, the bigger the numbers, the more difficult it is to find their GCF, and 231 and 1001 are quite big numbers. Luckily, there is a technique we can use to quickly find the GCF of 231 and 1001. We can try to divide both numbers by prime numbers, starting from the lowest possible prime number. Let's do that now. Since both 231 and 1001 are odd numbers, we already know that they are not divisible by 2, so we can skip the lowest prime number 2, and start with 3. 231 divided by 3 is 77, so 3 and 77 are both factors of 231. 1001 divided by 3 does not result to an integer, so 3 is not a factor of 1001. But how about 77? Let's give it a try. 1001 divided by 77 equals 13. Yes. 77 and 13 are both factors of 1001. Therefore, 77 is possibly the GCF of 231 and 1001. Let's now divide both 231 and 1001 by 77 and see if the result is a fraction in its lowest term. 231 divided by 77 over 1001 divided by 77 is equal to 3 over 13. Both 3 and 13 are prime numbers, so yes, 77 is indeed the GCF of 231 and 1001, and 3 over 13 is indeed the lowest term of 231 over 1001.
Question number 13. 40% of what number is 25% of 40? A. 20. B. 25. C. 30. D. 40. The correct answer is B. 25. Here's another simple percentage problem that some test takers find to be just a little bit confusing. 40% of what number is 25% of 40? Let x be the number we are looking for. Therefore, 40% of x is equal to 25% of 40. In equation form, 0.40x equals 0.25 times 40. From here we can simply solve for x, and should quickly arrive at x equals 25. Did you notice something peculiar with this percentage problem? 40% of 25 equals 25% of 40. The percentage and the number it is applied to can be swapped and they will still result to the same number. This is always true for percentages. Try it yourself with other percent and number combinations. 30% of 50 equals 50% of 30. 12% of 35 equals 35% of 12. 200% of 11 equals 11% of 200. And so on. Amazing, right?
Question number 14. Evaluate 123 times 0.1 plus 123 times 0.01 plus 123 times 0.001. A. 13.653. B. 135.53. C. 1356.3. D. 13,563. The correct answer is A. 13.653. This is another simple problem involving multiplication and addition of decimal numbers. So let's go ahead and quickly do the multiplications and additions, making sure to observe PEMDAS rule in the process. We should arrive at 13.653 as our final and correct answer. By the way, you may find it easier and faster to list down in a column and vertically add the intermediate answers from the multiplications. If doing so will save you a couple of precious seconds, then go ahead with it.
Question number 15. Which of the following has the greatest value? A. 8 over the quantity 6 squared times 8 squared. B. 16 over the quantity 6 squared times 8 cubed. C. 1 over the quantity 6 cubed times 8 squared. D. 168 over the quantity 6 raised to 4 times 8 cubed. The correct answer is A. 8 over the quantity 6 squared times 8 squared has the greatest value among the answer choices. This looks like a very daunting problem, doesn't it? Again, the key here is to use a technique to solve the problem in much less time than ordinary. Let's examine and evaluate each answer choice, but instead of computing for the exponents and the denominators and multiplying them outright, let's try to find a common factor among the answer choices. At first glance, what seems a common factor among the answer choices is 1 over the quantity 6 squared times 8 squared. Factoring out this common factor from each of the answer choices we have. For answer choice A, it is 8 times the common factor. For answer choice B, it is 2 times the common factor. For answer choice C, it is 1 over 6 times the common factor. For answer choice D, it is 7 over 12 times the common factor. Comparing 8, 2, 1 over 6, and 7 over 12, it is now very easy to pick out 8, or answer choice A, to be the one with the greatest value.
Question number 16. If 8 less than the product of a number and minus 3 is greater than 7, which of the following could be that number? A. Minus 6. B. Minus 5. C. 5. D. 6. The correct answer is A. Minus 6. Let x be the number. Now let's write the equation as minus 3x minus 8 is greater than 7. Adding 8 to both sides of the equation, we'll get minus 3x is greater than 15. We then divide both sides by minus 3. Remember that the inequality sign changes direction when dividing or multiplying by a negative number. So we should end up with x is less than minus 5. This is where many test makers make a mistake. Because they arrived at a minus 5, and since there is a minus 5 in the answer choices, they choose minus 5 as their answer. Wrong. And it is a shame, since they already reached this far in the solution. We are looking for x, and we arrived at x is less than minus 5. Therefore, x cannot be minus 5. Which of the answer choices is less than minus 5? It is minus 6, so minus 6 must be the answer. Don't make the same unfortunate mistake, okay?
Question number 17. A house and lot are sold for 14 million pesos. The house costs 1.5 times as much as the lot. How much does the lot cost? A. 5.6 million pesos. B. 8.4 million pesos. C. 10.5 million pesos. D. 21 million pesos. The correct answer is A. 5.6 million pesos. Let H be the cost of the house, and L the cost of the lot. H equals 1.5 L, let's label this as equation 1. H plus L equals 14 million, let's label this as equation 2. Substitute equation 1 into equation 2, and solve for L. We should quickly arrive at 5.6 million as the cost of the lot.
Question number 18. The lengths of the sides of a triangle can be represented by 3 consecutive integers. The perimeter of the triangle is 96 centimeters. Find the length of the longest side of the triangle. A. 31 centimeters. B. 32 centimeters. C. 33 centimeters. D. 34 centimeters. The correct answer is C, 33 centimeters. Let x be the length of the first and shortest side of the triangle. Since the lengths of the sides are consecutive integers, x plus 1 must be the length of its second side, and x plus 2 the length of its third and longest side. Since the perimeter of the triangle is given, we can proceed to write the equation as follows. x plus 1 plus x plus 2 equals 96. From here we can solve for x, and arrive at x equals 31 centimeters. We are being asked for the length of the longest side, so we solve for x plus 2, which is 33 centimeters.
Question number 19. A starting salary of an entry-level employee at ACI Systems is 15,000 pesos a month. Next year the starting salary will be raised to 18,000 pesos. What is the rate of increase in the starting salary? A. 3%. B. 20%. C. 25%. D. 30%. The correct answer is B. 20%. To compute for the rate of increase, we divide the increase by the original pay and then multiply by 100%. The increase is, of course, the difference of the new or future salary, which is 18,000 pesos, and the current salary, which is 15,000 pesos. We should quickly arrive at 20% as the rate of increase.
Question number 20. The length of a rectangle is 8 meters more than twice its width. The perimeter is 112 meters. What is its area? A. 16 meters. B. 40 meters. C. 56 square meters. D. 640 square meters. The correct answer is D. 640 square meters. Recall the formula for the perimeter of a rectangle. Perimeter equals twice the length plus twice the width. But the length is given as 8 meters more than twice the width, so let's plug that into the formula. And from the resulting equation we should be able to solve for the width, which is 16 meters. Recall again that the length is 8 meters more than twice the width. Now that we know the width, we can find the length using this information. We'll arrive at a length of 40 meters. But we're not done yet. What is being asked is the area of the rectangle. Recall the formula for the area of a rectangle. It is simply length times width, of course. So we plug in our computed values for the length and the width, and we should arrive at 640 square meters as our final answer.
Question number 21. When the original price of a pair of shoes is increased by a certain rate, the increased price is 3,100 pesos. When the original price is decreased by the same rate, the decreased price is 1,900 pesos. What is the original price of the pair of shoes? A. 2,800 pesos. B. 2,500 pesos. C. 1,200 pesos. D. 200 pesos. The correct answer is B. 2,500 pesos. Let X be the original price of the pair of shoes. When the price is increased by a certain rate, the original price X is equal to 3,100 over the quantity 1 plus the rate, or let's label this as equation 1. When the price is decreased by the same rate, R, the original price X is equal to 1,900 over the quantity 1 minus the rate. Let's label this as equation 2. We can equate equations 1 and 2 and solve for the common rate, R. We should arrive at R equals 24% or 0.24. Now we can solve for the original price, X. We substitute our computed value of R to either equation 1 or 2. Let's do it with equation 1. We should arrive at our final answer of 2,500 pesos. Try solving for X using equation 2. You should arrive at the same answer.
Question number 22. A race car traveled for 2.5 hours, with an average speed of 132 5/8 kilometers per hour. Find the total distance it covered. A. 264 5/16 kilometers. B. 331 9/16 kilometers. C. 330 5/16 kilometers. D. 135 1/8 kilometers. The correct answer is B. 331 9/16 kilometers. Recall our distance formula, given speed and time. Distance d equals speed s times time t. This is a simple distance problem where we are to simply plug in the given values of speed and time. What complicates it a bit is that the values involve mixed numbers. Since the use of calculators is probably not allowed in your exam, we propose to solve these as mixed numbers as given. First, we convert 2 and 1/2 into its improper fraction form, 5/2. Next, we break 132 and 5/8 into 132 plus 5/8, and distribute 5/2 by multiplying it to 132 and then to 5/8. We can simplify the first term into 330 by dividing 132 by 2 and multiplying by 5. We then simplify the second term by multiplying the two fractions. It should end up to 25/16. 25/16 can be simplified into its mixed number form, 1 and 9/16. Finally, we can add the two terms, 330 plus 1 and 9/16, to arrive at our final answer, 31 and 9/16.
Question number 23. Mr. Gawi Run borrows 750,000 pesos from the bank and is charged 90,000 pesos interest. What rate of interest did the bank charge for the loan? A. 8%. B. 9%. C. 10%. D. 12%. The correct answer is D. 12%. To find the interest rate, we simply divide the amount of interest charged by the total amount borrowed, and multiply by 100. We should quickly arrive at 0.12 or 12%.
Question number 24. An electric range uses 12,200 watts per hour and is run an average of 60 hours a year. How many kilowatt hour is this? A. 7.32 kilowatt hours. B. 73.2 kilowatt hours. C. 732 kilowatt hours. D. 7,320 kilowatt hours. The correct answer is C. 732 kilowatt hours. To get the kilowatt hour consumption for the given period, we simply multiply the number of watts used per hour, that is, 12,200 watts, by the average number of hours of usage per year, which is 60 hours. Let's not forget to divide the product by 1,000 watts to convert it to kilowatt hours. We should quickly arrive at 732 kilowatt hours as our answer.
Question number 25. Patricia is twice as old as Catherine. 7 years ago the sum of their ages was 16. How old is Catherine now? A. 8. B. 10. C. 16. D. 20. The correct answer is B. 10. For age problems, we always recommend that you set up an age table. For this particular problem, we've set up the age table for you, as shown. There are two persons involved, Patricia and Catherine. There are also two time frames involved, now and 7 years ago. We let X be the age of Catherine now. It is also what we are asked to find in this given problem. Patricia is twice as old as Catherine, so Patricia's age now must be 2x. From their current ages, we can therefore say that 7 years ago, Patricia's and Catherine's ages were 2x minus 7, and x minus 7, respectively. The problem states that 7 years ago the sum of their ages was 16. Therefore, 2x minus 7, plus x minus 7, equals 16. From here we can solve for x. We should quickly arrive at x equals 10. Therefore, Catherine is now 10 years old.
You have just completed Civil Service Exam Reviewer number 3, featuring questions on numerical ability. If you wish to watch more Civil Service Exam Reviewers on numerical ability, check out our Civil Service Exam Reviewer for Numerical Ability playlist. Check out also our other Civil Service Exam Reviewer playlists for other reviewer topics.
If you haven't done so yet, please don't forget to subscribe to Review Central, and click or press the bell button to make sure you get notified whenever we post a new reviewer or other review materials on this channel. Please like if you find this video useful, and feel free to share to anyone who may also benefit from it.
We wish you all the best on your forthcoming civil service exam and for a lifelong and fulfilling career in government service.
Mabuhay.
Mabuhay.